Hello guys, welcome back to another video. In this video, we are going to see how to use the multi-stage Docker builds inside a Docker engine and what are all the advantages that we are getting with the multi-stage Docker containers or maybe the Dockerfile. First, we need to understand the basic Docker build process and then we'll jump into the multi-stage Docker builds. To understand this better, I have created a PPT. Let's go through this. Imagine you have a Docker file with a couple of instructions. As you can see in the screen, take this as an example. So this Docker file consists of 5 instructions. First one is the from instruction, and the next two are the run instructions, and the fourth one is the copy instruction, and fifth one is the cmd instruction. Each line in the Docker file creates an intermediary container to execute the Dockerfile directive for that line. Let's say you have submitted this Docker file to the Docker engine by executing the docker build command. Once the Docker engine execute this Docker file, first it will try to take the first instruction in the file. As first instruction is the from instruction, it will take the first instruction and it will try to run inside a intermediary Docker container. Once the execution is completed, the intermediary container will commit as an layer and we can name this layer as a layer 1. Once this is completed, the intermediary container will be deleted. Next, the execution will proceed to the next second instruction and it will take that instruction and it will try to execute inside another Docker intermediary container. Once the execution is completed for the second instruction, it will commit as another layer. We can name this as a layer 2. As usual, the intermediary container will be deleted. And then next it will proceed to the third instruction and the Docker engine will take this third instruction and it will try to execute inside a intermediary container. Once the execution is completed, then it will commit as another layer called layer 3. Once that is also completed, then the intermediary container will be deleted. Next, it will proceed to the fourth instruction and it will try to execute the fourth instruction inside a intermediary container. Once this is also completed, then it will commit as another layer called layer 4. Then it will delete the intermediary container. Finally, it will proceed to the last instruction. Here we have the last instruction is the cmd instruction. Then it will try to execute inside a intermediary container. Once it is completed, then it will commit as another layer. Once all the instructions are executed inside the Docker file, then the Docker engine will group all these layers together and we can take this as a Docker image. And inside this Docker image, all these layers are read-only layers. We cannot perform any changes. We cannot change anything inside any layer of this image. Guys are clear about the basic build process. Let's jump into the multi-stage Docker build. As you can see, this is a single Docker file. In this Docker file, we have a couple of instructions. And if you observe clearly, we have 2 from instructions in the same Docker file. One is on the top and the second one is over here. And the moment when you use the second from instruction, from there onwards, we have to call it as stage 2. Once you have the first from instruction, till the next from instruction, we have to call it as stage 1. Once you mention the second from instruction, from there onwards, we have to call all the lines, all the instructions are stage 2 instructions. And also if you observe carefully, in the first stage 1 from instruction, we just mention an extra words called as build. With this as keyword, we are just providing a name to the first stage as build. And as you can see, in the second stage we are using the copy module, and if you can see, we are using hyphen hyphen from is equal to build. We are trying to copy few files from the stage 1 to the stage 2. So how this will happen inside when you submit the Docker file, how the Docker engine will create the multi-stage builds and all, we are going to see everything. And also we understand that how this Docker image is built in the first PPT, right? So imagine the first stage instructions are executed and then it creates the Docker image. Once the second stage starts, the Docker engine will try to execute, and then it will try to take the second stage first instruction and it will try to run inside another intermediary Docker container. Once the execution is completed, then it will create and it will commit as a layer in the second image, and we can name this layer as a layer 1, as you can see. Once this is completed, as usual, the intermediary container will be deleted. It will proceed to the next second instruction as we have a run instruction. It will try to create a intermediary container. Inside this intermediary container, this run instruction will execute. Once the execution is completed, then it will try to commit as another layer on top of it. We can name this as a layer 2. Once this is completed, the intermediary container will be deleted. If you try to understand the third instruction in the stage 2 very carefully, we are using the copy module and we are specifying a word called hyphen hyphen from is equal to build. Please copy couple of files, the required files from the stage 1 build process to the stage 2. Okay, at this time it will not create the intermediary container, but it will try to copy the files from the first Docker image to the second Docker image like this, and it will commit as a layer 3. And once this is also complete, then it will go to the end of the instruction and then it will try to create a intermediary container. Once the execution is completed, it will try to commit as a layer 4, and once this is also completed, then it will try to delete the intermediary container. Once all the instructions are executed, then the Docker engine will group all these layers together and it will give us like an image, and all these layers are read-only layers. I'm sorry guys, forget about this wrong name, so it should be layer 4. So it's duplicating, right? I just copy pasted, and we have to mention this as a layer 4. And once these two images are created, finally the first Docker image will be deleted, right? And then the second Docker image will be maintained as the main Docker image. I hope you understand the procedure. Let's try to demonstrate this and we'll see what are all the advantages that we are getting with the multi-stage builds. Let's go to the Windows server, and here you can see this is the typical Docker file that we have used to build the Docker image for the Jenkins. As you can see, let me increase the font, go to the properties, font, and then make it 20, and then click on OK. Let me increase the size as well. Okay, so if I do Docker images, here you can see our Jenkins image size is 6.15 GB, which is very huge, right? So we'll try to use the multi-stage Docker here, and then we'll try to reduce this image size to, let's say, less than 1 GB, right? So for that I have created a Docker file. Let me open it. Open folder, inside the C drive, go to Docker stuff, and then I have created a Jenkins tiny folder over here, and then select this folder. Alright, so as usual we have a Docker file over here, and the dependency software also we have copied over here. So the Jenkins war file is there, and then Java binary is also there. So let's go through the Docker file first. This is a multi-stage Docker file. How can we say? Right, so we have two from instructions. As you can see, this is the first from instruction, and also we have a second from instruction as well. From up to here we can call this as a stage 1, and from here to end of the file you have to call this as stage 2, right? So as you can see, first image I'm taking as old image, like mcr.microsoft.com Windows Server Core LTSC 2019. This image size is very huge. Here you can see the size is 4.94 GB, right? So on top of that we have installed JDK, and then we have installed Jenkins, so that the Jenkins image size is increased to 6.15 GB. Right, so the base image size is 4.94 GB, and then the Jenkins image size is 6.15 GB. Let's try to reduce, let's try to understand this Docker file, the multi-stage Docker file. As usual, I have taken this as a base image for the stage 1 instructions, and I'm just naming this stage, the first stage, as build. We can provide any name. Instead of build, we can provide any name we can provide to the stage, and we have to use the as keyword. If you want to assign any name to your stages, then we have to use the as keyword, right? And we are creating a dependency directory inside a intermediary container, and then we are adding the java.exe file into the container, and then we are installing the Java inside the intermediary container. And finally, these 4 instructions, what it is doing is, it is taking the base image as server core LTSC 2019, and it is creating the dependency directories inside the intermediary container, and then it is installing and it is adding the Java package, and finally it is installing the Java software inside the intermediary container. With all these 4 instructions, we are installing the Java. Once Java is installed, next in the second stage, we are taking another image called mcr.microsoft.com/windows/nanoserver, and the version is 1809. So these nano servers of Windows are very lightweight in nature, right? So we are going to see what will be the size of this nano server in once we completed this explanation. We'll try to build image, right? So at the time we'll try to see what is the size of the nano server. Once this second stage starts, then we are copying couple of files from the build stage, right? So this is the first is the build stage, right? From there we are trying to copying all the Java files from the first instruction, not first instruction, from the first stage to the second stage of the Docker. And so from here, from the first stage, so whatever the softwares, whatever the packages that is installed with the Java, when you install Java inside a Windows, it will try to install, let's see, program files and then Java. That inside the Java folder, it will try to create lots of folders, and then it will try to extract so many things, and it will try to create some of the binaries so that you can execute any Java commands inside the server, right? So in the first stage, we are installing the Java. Once the Java installation is completed, finally it is starting the second stage. Once the second stage execution starts, it will try to copy all the executable files from the first stage to the second stage from this copy instruction, right? And you can see this is the source and this is the destination. All right, once that is completed, we are creating a folder inside the container, and then we are copying the Jenkins var file to this container, and we are providing just try to use this user to run the container. And when you run any Windows container, you can get two users: container user and container administrator. Container user is the normal user, and that user doesn't have any privileges, I mean sudo privileges, I mean super user privileges. But inside the Docker container, if you use Windows Docker, container administrator is the user. This user is having root privileges like sudo privileges, super privileges this user is having. And then we are setting an environment variable Java home, and a second environment variable is Jenkins home, and we are exposing two ports, 8080 and then 50,000 ports, because Jenkins required these ports. And then we are exposing the volume as well. And then finally we are running the Java command to run the Jenkins. Here you can see this is the path of the Java executable, and then we are providing a flag called -jar, and then we are passing some of the arguments is the jar file. And if you observe here, I have just provided the Java home environment variable. So when you use the nano servers images, so the environment variables are not working. So that's the reason I have used absolute path to call the Java binary over here. All right, so this is the path of the Java, and once you build this image and once you run the container from this, you will be able to run the Jenkins inside a Windows Docker container. All right, I hope you pretty much clear with this Dockerfile. Let's go and build the Docker image first. As you can see, we have only 3 images. So what I'll do is I'll just change this directory to Jenkins tiny, and here you can see we have 3 files, including the Dockerfile. We have the dependency softwares as well. Let's try to use the docker build command and then -t, and in this case I'm just giving another name to this image, my Jenkins tiny. Okay, and then in the current directory, so we have the Dockerfile and the remaining stuff. Let's execute this. All right, it executed the first stage. Once the first stage is completed, then it will go to the second stage. Now currently it is installing the Java package inside the first stage. It will take time, guys. I'll pause the video over here. Once it is completed, then I'll try to resume the video. Alright, so if you observe, the Docker build process is completed, and here you can see the successful message over here. Let's try to observe the image sizes. So I just executed docker images command. If you try to observe, the server core image size is approximately 5 GB, and the nano server image size is 251 MB. So from 5 GB to 251 MB, which is very huge difference, right? So, and also try to understand the difference between the previously built Jenkins and the tiny Jenkins image. And here you can see this is the previously built my Jenkins image, and the size is 6.15 GB. And if you try to observe my Jenkins tiny just now 30 seconds ago, the size is 893 MB. Try to understand the difference from 6.15 GB to 893 MB, which is very huge difference, right? So this is how we can use the multi-stage Docker builds to reduce the Docker images. And I would like to tell you one point over here. So why we used server core LTSC first, and then why we use nano server second? So why can't we use nano server directly instead of using the multi-stage Docker builds? And try to understand, guys, this nano server is very lightweight in size, so only the required softwares that are included in this image. You cannot execute, you cannot install any PowerShell commands or any Visual Studio Code dependency softwares you cannot install in this nano server. So if you want to experience that, just try to download this image first and then try to install any command or any package inside this nano server. I just tried it and it's not working. So that's the reason to install the Java I took this server core, because all the necessary softwares that are available inside the server core, and then I could able to manage the Java installation with this run instruction. Once the Java is installed, and then I'm able to copy from the stage 1 to the stage 2 using this copy -- from command, so that I can able to get the all the executable files of Java. And on top of that, I am just running the Java command inside the container to initialize the Jenkins. Okay, so we understand the difference, and clearly there is a huge difference in the sizes. And now we'll try to validate whether this image is working perfectly as expected or not. I want to run a container with this. All right, so as you can see, I'm using the my Jenkins tiny image, and I want to mount a named volume called Jenkins data, and then I want to mount inside the Docker container directory is C Jenkins, because at this location only we are initializing the Jenkins, and this is the Jenkins home directory inside the Docker container also. And we are exposing 2 ports of your host operating system and then the container as well. So the first port is 8080 and then other one is 50,000. Let's go to the Docker volumes and then try to understand, do we have any Jenkins data folder is there or not. So previously we have this folder. Let's try to delete this to make sure everything is clean. As you can see, the Jenkins data folder is deleted, the Jenkins data volume is deleted. I'm inside the root volume of the Docker. Here you can see C program data Docker volumes. Let's try to run this command. Guys, when you face this kind of error when you are executing any Docker run commands, there is a workaround. Just stop the service and then start the service of Docker. To stop the service, we have a stop service command, and then the service name is Docker, and then start the service using the start service command. All right, just try to execute the same command, same Docker run command. This time you will get a success. All right, so the Jenkins initialization is started. Any moment you can see the initial password over here. All right, so let's go back to the Docker volumes, and here you can see again the Jenkins folder is created over here. If you go to the data directory, here you can see the Jenkins data. The Jenkins is running inside the Windows Docker container, which is very lightweight. The image is very lightweight. The size is 895 MB, and here you can see the Jenkins is running inside the container, and this is the password. Just grab it, and I want to open another Chrome browser. Okay, browse localhost 8080. If all working good, then yeah, so it is asking for the initial password. Just type it, just paste it, and then click on continue. There you go, it just took the password and it is asking for the install suggested plugins. All right, so it will install all the plugins as expected, and I hope you guys are very happy with this video. So we have learned so many stuff here, and the stuff like multi-stage Docker builds and why it is useful, and also we understand that how we can reduce the image sizes of Windows Docker, right? I hope you guys have liked it, and please subscribe to my channel and share this video as much as you can. Thank you. I'll see you in the next video.